Okay, so today we are going to begin our chapter working with matrices. Okay, singular, matrix, plural, matrices. Okay. Anybody get it? Okay. Good. I know it's an old movie. It came out when I was in high school. Just wanted to try that. How many of us have seen it? Awesome. Okay. You guys are making me feel old. All right. So what is a matrix? A matrix is a rectangular array of numbers. Much like this. Really?
Yeah, I know.
It kind of looks like a table, right? Without actually being a table. Okay? So it's just a rectangular array of numbers. We have rows and columns. And then we have these little bracket things around the entire thing. So we know that it is a matrix. Each number inside that matrix is called an entry. Okay. So 5 is an entry. Okay. I don't know how often we'll really use that term, but you know it. Okay. And then to describe matrices, okay, we can have matrices of all sorts of different sizes. So right now this matrix has 3 rows and 2 columns, okay? So in order to compare matrices, we're going to learn how to like add, subtract, and multiply matrices. We have to have certain things match up with rows and columns when we do those sorts of things. So when we describe matrices, we describe them by their order. Okay? The order describes the number of rows by the number of columns. The number of rows by the number of columns. So, how many rows does this matrix have? 3. How many columns? 2. So we say that this is a 3 by 2 matrix. And then we have some special matrices that will have special properties later. When our number of rows and columns are the same, we say that that's a square matrix. I'm sure you can see why we would call it a square matrix. All right, but we're going to have some special things that happen with square matrices. So I want to make sure we talk about they are square when we have the same number of rows and columns. A lot of what we do today is looking at what matrices are, kind of some things that we can do with them. We're going to be doing a lot of setting up today, and then we'll do a lot more calculating tomorrow. Okay. So let's look at some matrices. I have 4 matrices written up here, and I want us to determine the order of each of these. Okay, so A, how many rows does that one have?
1.
How many columns does that one have?
1.
Okay, so what's our order? Okay, let's move to C. What is the order of C?
2 by 2.
Okay, when we have the same number of rows and columns, square matrices, those are easy to determine the order. Okay, but you need to be careful. What is the order of B? 1 by 4. Rows by columns. Rows by columns. Okay, And D,
3.
okay, 3 rows by 2 columns. Okay, this is going to be the first part of your homework. Okay, I know this seems very simple, but it is very important because when we talk about adding, subtracting, and multiplying on Wednesday, order is going to be a very big deal when we do that. We can only add when we have a certain kind of order. Okay, so we just got out of working with systems of equations. Matrices can actually help us solve systems of equations, and by the end of today, you'll kind of see how they can be helpful. So what we can do is we can actually take a system of equations and we can write an augmented matrix out of it. Okay, so I want everybody to write down that systems of equations. Write down those 3 equations for me, please. So what's going to happen is we're going to take the coefficients from all of our variables and we're going to make them into a matrix as well as what's on the other side of the equal sign. Okay? So we're going to make a column of all of our x coefficients. So what's our first x coefficient? Okay. Our second equation? And our third equation, 2. So those are all the coefficients of x. Our next column, we're going to make for y. So what's our coefficient for y in the first equation? -4, the second equation, and the third equation. Great. And then our z's are, what is our first coefficient for z? In the second equation, and our third equation, -4. So there's all the coefficients. X minus 4y plus 3z, we're going to put a colon, and then 5. -x plus 3y minus z equals -3. And 2x plus 0y minus 4z equals 6. Okay, so we've taken a systems of equations and we've put it into an augmented matrix. We call it an augmented matrix because we have like this extra column with those colons separating the two. Okay, it's augmented with what those coefficients are equal to. Okay, what we're going to be able to do with this is eventually use a matrix to help us solve for x, y, and z. Okay, so what I want you to do is take this system of equations and write the augmented matrix for me. I'll give you 1 minute to do it. Excellent. Do you agree with Michael's matrix? Good. He has a 0 in that second row because the second equation doesn't have a z. Okay. What is the order of this matrix? 3 by 4. Very good. The order of this matrix is 3 by 4. Okay.
And we have to write that on the side of it.
You wouldn't have to, no. I'm just going to ask you a lot about the order so we know what I did play. Okay. All right. So we're going to come back to the idea of this augmented matrix here in a little bit. But I want to tell you about some things that we can do with matrices. Okay. We can actually take our matrices and we can work with the rows and basically rearrange how our matrix looks to help us. Okay, I'll tell you why in a little bit. This is going to help us, but first let's talk about what is legal. Okay, so all of these operations that we can do with one matrix only work if we're changing rows. Okay, not columns, just the rows. Okay, so the first thing we can do is interchange two rows. Okay, so I'm going to make up a matrix. Matrix 1, 2, 3, 4, 5, 6. Okay, we can interchange two rows. So I can take row 1 and row 2 and we can make them swap places. As long as everything goes together, the entire row still stays together, we can go ahead and we can switch rows. Okay? If we think of like systems of equations, that's just kind of the same thing as writing one equation first and the other one second, and vice versa. Okay? It doesn't matter which one we write down on our paper first. Okay? So we can switch the rows. All right? We can also multiply a row by a non-zero constant. So I can take this matrix, and it is possible for me to just multiply one of these rows by a number that's not 0. So I'm going to say -4 times row 1, and then we can write this as -4, -8, -12, 4, 5, 6. Okay. That is legal. It is also okay to add two rows together or add a multiple of a row to another row. So you can either just add two rows together or take a multiple of a row and add it to the second row. Okay? That doesn't mean you have less rows, you would just be replacing one of your rows. Okay, so here's my original matrix again. All right, what we're going to do is we are going to take -4 and multiply it to row 1. That's what we did in the second one, right? And we're going to add it to row 2. And that's going to become our new row 2. Okay? So when I take -4 times row 1 and I add it to row 2, what are our new three numbers for row 2? 0. -4 times 2 plus 5 would be -3. -4 times 3 plus 6 So we can keep row 1 as is, but we just took row 1 and multiplied it by -4 to add it to the other row. So we still have the same number of rows even though we combined two of them together. Anytime you do these row operations, okay, we say that they are row equivalent, okay? So my blue matrix is the same, okay? All of those red matrices, those are row equivalent to our blue matrix because we use the blue matrix to switch things around as far as the rows are concerned. Okay, so they're row equivalent. Okay, so we're going to practice a couple of row operations. In your homework, you'll have a few problems where they are going to give you a matrix, and they'll say, do this operation, and then do this operation, and write me the new matrix. Okay? We can do as many row operations as we want to. Okay? We're going to do one at a time right now, but tomorrow we're going to be able to string like 5 or 6 of these together, okay, to help us out. So go ahead and write this matrix down. Okay, so the first thing I want to do is switch row 2 and row 3. So row 1, it gets to stay the same, right? So I can write 1, -4, 3, 5. Then what would I write? Good. All of row 2 just gets moved up. And then my new row 3 is now okay. So now we've switched row 2 and 3. Cool. Now I want us to add row 1 to row 3 and replace row 3. Okay, so row 1 and row 2 get to stay the same, correct? So I'm going to go ahead and write them the same. Okay, so now if I want to add row 1 and 3 together, what would we get for this first number? 0, -1, 2, and 2. Okay. So all 3 of those matrices are row equivalent. All right, and we can keep going with some more operations, but we're going to practice more of that tomorrow as far as what operations we should do and why. Okay, we need to talk about a couple special forms of an augmented matrix. Okay, so there's 2 special types of forms. The first is called row echelon form. Okay, row echelon form means, first of all, if there's a row of zeros, it goes to the bottom. All other rows have the first non-zero entry as 1. What does that mean? Okay, if there are 3 numbers, then they could start with 1 or 0, 1 or 0, 0, 1. Okay, the first non-zero term has to be a 1. And then write it down, and I'm going to show you what it means. But for 2 successive rows, the leading one in the higher row is farther to the left than the lower row. I will show you what that means. So write it down for now. This is a matrix in row echelon form. Okay. Notice how the first non-zero term is a 1, right? And then the ones, okay, so the leading one in the higher row is further to the left than the lower row. So if there's 1 0 in front of the 1, that needs to go in my second row, right? And then these two, this row has 2 zeros, so it needs to go under that. So all of these, the 1 is further to the left. How I like to kind of describe this is there ends up being a seatbelt of 1s, where below the seatbelt of 1s will be a triangle of 0s. Okay, but to get this, or row echelon form, we get this seatbelt of 1s across the diagonal. Okay, and then all of these numbers end up being 0s. Okay. Reduced row echelon form. Reduced row echelon form just means that now there are zeros above and below every leading one. So we still have that seatbelt of 1s, but now there's zeros above and below it. Okay, so you have a seatbelt of 1s and everything else is zeros as far as in that square part. Okay, you're still going to have values over here, and I'll show you why in a little bit. But over here in the square part, you're going to have the seatbelt of 1s and everything else is zeros. Okay, so why does this matter? Okay, so I've told you what a matrix is. We know how to find the order. We know how to write an augmented matrix. Okay, and now we have all this stuff about row operations and these funny words for the form. Okay, row echelon form and reduced row echelon form. Okay, why is that a big deal? Let's talk about why. Okay, so what kind of form is this?
Row echelon.
This is row echelon form. We have that seatbelt of 1s and then with the zeros underneath, but then these are other numbers, so it's just row echelon form. Go ahead and write this matrix down. Now, not all matrices stand for equations, but when we have an augmented matrix, it represents a system of equations. Is this an augmented matrix? Yes, it is. We can tell by these right here, right? So since this is an augmented matrix, we can write it as a system. How would we write this? Good. What about the second row? And the third row? How easy is this to solve? Very. We know z equals 2. What can we do with that? Go back to the second equation. Y minus 2 equals 2. What is y?
4.
Thank you.
Wouldn't be y minus.
Oh, thank you. Y minus -2. So what's y? Thank you. And then what can we do?
Plug it in.
Go to the first equation, x minus y plus 2z equals 4. What's x?
0.
So the solution to this system is 8, 0, -2. Why was that so easy to solve? Because it was in row echelon form. Do you see where this may be going? Okay. Now what about if it was in reduced row echelon form? What does this mean? X equals 5. Y equals 3. Z equals 2. Pretty sweet, right? Okay. So eventually, like, I don't know, we're going to be able to take matrices and put them into these forms to solve. But for now, we're just going to practice the setup. Okay, so this homework is going to take you through identifying the order of a matrix, writing the augmented matrix, or taking the matrix and writing the system of equations. Okay, it'll have you do a little bit of solving, but only if it's in row echelon or reduced row echelon form. And there will be some problems where I'll have you do some elementary row operations. Okay. Tomorrow, bring your calculators because we get to do some matrix stuff with our calculators. And it's